Hey guys, thanks for joining me on Code Quest. This is Sanchit, and in this video, we're going to go through the implementation of Dijkstra algorithm in Java language. And uh, in the last video, we went through the algorithm with a basic example, it's really important that the people understand, the basic concept of this algorithm to then only you'll be able to understand this code as well. So yeah, and I also expect people that you already have some experience with the Java language actually. Okay, so let's get into this. So yeah, okay. So here's the thing. So let's start the code actually. So uh, don't worry about this thing here. I'll explain it later. Uh, let's start with the code directly. So we have to write a class for graph actually. Here I've used it right here I've used a class graph, and I've initialized it here. And uh, this is just I'm just adding the nodes and wait for the graph, and then yes, this is where I'm executing the algorithm. I'll show you how to I'll just write the code and I'll explain you how to do this. Okay, so let's get started. So yeah, okay. So let's start with this class. Okay, so again, I'm going to tell you this. I'm going to use priority queue as a base thing to implement this algorithm using Java actually. So yeah, so here V is nothing but the number of nodes, okay? The number of vertices in the graph, okay? So this is V. Then what we have is going to now we need a data structure to store the graph, right? So we're going to use a nested list object, okay? A nested list object to store a graph, to store the graph. And what we're going to do is, uh, while storing the graph, we're going to store it as uh, this is how we're going to store it. Just have a look here. So this is how we are going to store it. Okay. So let's consider a list kind of thing. So each index is going to refer to a node as well. Okay. So and each index is going to be will also contain a list. Okay. Let's say we have let's say we have uh, 1, 2, 3, 4, 5, 6 nodes. Okay. Let's say we have 6 nodes. So we'll have 6 indices from 0 to 5, and we'll have 6 nested lists as well. Okay, so let's see. Okay, so this is how we're going to store this. Okay, so what we're going to do is in each nested list, we're going to store the neighbors. Okay, as as pairs. Okay, we're going to store the neighbors as pairs. Okay, let me show you how this is going to get stored in the nested list actually. This is just an example, so don't confuse this with a problem. I'm just giving an example. Okay. So yeah. So this is how we're going to store this. Okay. So if you look at this, this, this index corresponds to the first node. This index this index corresponds to the second node. This index corresponds to the third node. This index corresponds to the fourth node. This one to the fifth. This one to the sixth. Okay. So each index contains a set of each index is again a list. Okay. So this is a list. This is a list. This is a list. This is a list. This is a list as well. So each index contains pairs. Okay. Pairs of what? Nothing but so how should I put this? So each index is going to contain uh, the destination. Okay, so sorry, the neighbor and the weight. Okay, so this is how it works. So let's say let's consider this example that we have used in the previous video. Okay, let me show you. So in this example, if you see uh, so in this example you have these nodes, right? So each index corresponds to these nodes. Okay, well, you have 6 nodes, and each index corresponds to these 6 nodes. And how we are going to store it as is, let me show you. So for the first index, for the first index denoting this node, what we will have is, let's consider this node as 0. Uh, this just These are just names, just consider it that way. Okay, so this is the 0th node. This is the first node. This is the second node. This is the third node. This is the fourth node, and this is the fifth node. Okay, so you have 6 nodes. So I'm naming it from 0 to 5 because in Java indexes start from 0 to n minus 1. Yeah. So let's consider it that way. Okay. So this is how it works. Okay. So you have the first node as 0. So what are its neighbors? 1 and 2, right? So what you're going to do is you're going to have a list. Okay, another list object uh, in this position, and you're going to store it this way. You're going to store its neighbors as pairs of the neighbor, which is 1, right? The neighbor is 1, comma, the distance, the weight is 4, right? So you're going to do this. Okay, so again, for this again you'll have 2 comma 4, right? Sorry about the editing, guys. Okay, so it's 2 comma 4, right? So to do for the neighbor to reach it from the source node, sorry, the current node 0, it's 4, right? The weight is 4, right? So you're saving the sorry you're storing it in that way. So what you're essentially doing is, yeah, what you're essentially doing is, let me show you. Yeah, so what you're essentially doing is you're storing uh 1 comma 4. Okay, so this has 2 neighbors, right? So you don't need this another pair, and 2 comma 4. You understand this? So this is the 0th index. Yeah, the 0th index. Uh, it has a list, and it stores the neighbors and the weights as pairs. Okay, so the neighbor is 1 and 2, and the weights are 4 and 4, right? So you're going to store it this way, and similarly you'll store it for everything. So if you go there and if you go to that example and check it, you'll see that uh, the for this first node, you have 0th node as a neighbor. Sorry. So for the first node, you have the 0th node as a neighbor, right? The 0th node as a neighbor, and the second node also as a neighbor. Okay. So for the first node, what you'll do is you'll store 0 comma 4 and 2 comma 2. Yeah. Am I making sense in that way? Okay. So what I'll do is, what essentially I'm going to do is, I'm going to store it this way. So for the first node, it's going to be 0 comma 4 and 2 comma 2. Yeah. So this is how it works. Okay. So that's what I'm going to do. So in order to store as pairs, okay, in Java we don't have any kind of data structure for that. Well, we can store it as a list and all that, but I'm going to uh, create a class for that. Okay, called pair. What essentially I'm going to do is it's going to contain two integer values. That's it. Okay, in first and in second. The second value is going to be, of course, the weight, and the first value is going to be the node, right? Yeah. So we'll write a constructor as well. Yeah. So this is how it works. Am I making sense? I hope I'm making sense actually. Uh, if you have any doubts, you can ask me in the comments actually. So this is how it is done. Okay. So this pair object will do nothing. Will help us to store uh, these pairs. Okay. Yeah. So what you're going to do is you're going to store pair objects, right? So you're going to do that, and yeah, then you're going to name this as what? Mm, so this is adjacency list, right? Let's name it as okay. So let's write the constructor for this for this class. So as I said earlier, b is nothing but uh, the number of edges. In our example, it's going to be sets, right? So what you're going to do is adjacency list is equal to, you're going to create a array list object here. Yeah. Okay. uh, now uh, now since this is going to be nested array list, right? This is a nested array list, right? Yeah. What you're essentially going to do is you're just going to add uh, add like v new array list inside this list. Okay, inside this array list. Okay, so in is equal to, so you're going to add new array list, right? So you're going to declare array list object. That's it. Okay. Yeah. So this is how it's done. Okay. So now the constructor is ready. Now what you have to do is you're going to you need to you need a function to store the values actually, to store the values that you want to add. Okay. So what we'll do is we'll create a function for that. Okay. So it's going to be void add node. Add node. What it essentially does is it takes in the input and like helps us to create a graph. That's it. Let's explain it soon. So source, destination, node, and the so I'll write this and explain this to you. Okay. It is going to be a distance list action. So yeah, okay. So let's understand this. Okay. So what I'm essentially doing here is, so I'm assuming that this is an undacted graph. Okay. So let's see what's going on here. So in this line, we're simply adding nested lists. Okay, nested array lists into this list. Okay. We have declared a array list adjacency list. Inside that, we are adding v number of uh, ad- again array lists. This v is nothing but the number of nodes. Okay. So again, what you're going to do is uh, you're going to get the source, then the destination, and the weight. Okay. So what you're going to do is you're going to add the destination and weight pair to the source index, and similarly you're going to add the source comma weight pair to the destination index. So what this means is, if you see here, if you see in in this thing, this simple example that I've given here, what you're going to do is initially what you'll have is initially it's going to be like this, right? So initially you have a simple array list, right? So after executing this line, so this block of code, what this will become is you'll have sets. You'll, you'll essentially have sets nested lists, right? Yeah. Sorry. Yeah. You'll essentially have sets nested lists. Okay. So once this is done, so when you call a function, when you call the add node function, uh, and you want to add this path, let's say this one. Let's say you're going to add so 0 to 1 and 0 to 2. Okay, so you're going to add these two things. So what you're going to do is so since this is an undata graph, so 0 is 1 is the neighbor of 0 and 0 is the neighbor of 1 as well. Okay, so direction doesn't matter. So if you have a direct edge, so then they are going to be neighbors, right? So direction doesn't matter. So it's kind of vice versa. Okay, so let's see how this is done. So yeah. So what you're going to do is when you give source as 0 and destination 1 and weight as 4. So what it essentially does is uh, it's going to get the source is 0. So it's going to get this first array, yeah, the first array from this uh, the first array. So and it's going to add the actually. So it's going to get the first array and it's going to add a pair of destination and weight. So the destination is going to be 1 and the weight is going to be 4. And again, and in the second line, what you're going to do is you're going to do the vice versa. You're going to get the destination, which is 1, and you're going to add source and weight. Yeah. Since this is an undirected graph, uh, it doesn't the since this is an undirected graph, it doesn't matter whether uh, you know uh, yeah, the action doesn't matter. So it's simply you add the the neighbors, or if there's a direct edge, it's going to be neighbors. They're going to be neighbors. That's it. So you're going to add this as well. So yeah, this is what this block of sorry this function does actually. So when you add 2 comma 4, then so the other neighbor of 0 is 2, right? So when the source is when the source is 0, the destination is 2, and the weight is 4. This is what is you're going to do. You're going to add 2 comma 4 here, okay? And in this index, sorry, in this array list, you'll here getting right. So you'll be getting like list dot get 2, and you're going to add a pair as source and destination, right? So it's going to be like uh 0 comma 4, okay? So this is how it works. This is how this function works, okay, guys? So now that's done actually. So now we are done with the graph. The only thing that's left for us is to uh, implement the logic actually, okay? Well, so now we're going to start another function again, and this is going to be the shortest path function that's going to execute this algorithm actually for us, okay? Going to execute this algorithm for us, okay? So yeah, let's see. You're going to get the source, okay? You're going to start with the source, right? So you're going to get the source, and as I said, we are going to use a priority queue, right? So I'll start with the priority queue. So this priority queue is going to store pairs of, let's explain that to you. So, yeah, so we have to give the we're going to define the length of the priority queue. This is going to be uh, the number of vertices. So this is dot v, and we need to give a comparator object, okay? So what I'm going to do is we are going to define a new comparator actually. Well, let's do this. Before that, we need to write the class, right? So before that, I'll explain you how what this priority queue is going to store actually. Essentially, what it's going to store is uh, a pair. Okay, it's going to store the distance to a node. Okay, from the source node. Okay, the distance to a node from the source node, comma, then that node. That's it. I'll show you how this is done actually. So you can so you people can see this, right? So yeah, so see what we are essentially going to do with that priority queue is, so when we are solving this problem, we will select this node. Let me show you this. Yeah, so once you have selected this node, right? Once you have selected this node, you'll be doing this, right? what we'll do is in the priority queue, let's consider this as priority queue. And sorry for the handwriting, guys. It's going to be always like this. Yeah. So what you're going to do is you're going to add this as a pair. The selected node, so the node, and and its distance from the uh, it, its distance from the source node. Okay. So so the distance from the source node for this node is 0, right? Yeah. So this is the source node, and the distance between the source node and the source node itself is 0. So 0 and the node, and the node is 0 actually. So if you, as I told you earlier, so this node is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. So yeah, when you solve this problem, you will update this value to 4 and this one to 4 as well. So when you're done with this, when you are updating this, what you'll do is you'll be adding that to to this priority queue. Okay, you'll be adding that to this priority queue. Okay, so the distance for this node from the source node is 4, right? So you'll be adding 4 and comma the node 1, and you'll be adding this as well. So 4 comma 2. So once you're done with this, actually you'll pop this one. Sorry, you will remove this one. You'll pull this one. Okay. So let me do this again. Yeah. So yeah. So what you'll do, what you'll essentially do is once you're done with, mm, once you're done visiting all the neighbors of a selected node, you will remove that node from the uh, priority queue. Okay. So then from the priority queue, you'll select which node uh, has the lowest distance. So sorry, the minimum distance has a minimum distance from the source node. So will be it can be anything, right? Four, sorry, one or two, right? Both has a distance of 4 4, so it can be anything, right? So maybe we'll select this one and continue with this problem. So when you continue with this, uh, uh, at some point you'll end up with this being, so only when you update it you'll be adding it to this thing. Okay, to this priority queue, you have to remember that. So let me show you this again. So you have updated it here, right? So when you try updating it again, you'll be trying this, right? 4 plus 2 is less than 4. The condition is not satisfied, right? Because 6 is not less than 4 in this case. Yeah. So since so you'll retain this 4 value. In this case, you won't be doing this. Now currently, let's say the priority queue is like this. At first, the priority queue will be empty. What you'll do is you'll add the first node. Okay, so it'll be like 0 comma 0 at first. Then you'll check whether the priority queue is empty. No, it's not. It has it has this value, right? 0 comma 0. I'm sorry, there's going to be a pair object within braces, so remember that as well. So you have 0 comma 0, right? So what you're going to do is you're going to pop this. So again this will become empty. You're going to, sorry, you're going to pull this and you're going to check all its neighbors, and if you're going to update the values of its neighbors, you're going to add it to the add it to priority queue. So once you visit all of its neighbors, you'll update it to 4 and 4 from infinity. So this priority queue will become 4 comma 1 and 4 comma 2, right? I'm really sorry about my handwriting, guys. Yeah. So this is 4 comma 1 and 4 comma 2. Okay. Uh, it's not that, but I'm just saying. Okay. So it's 4 comma 1 and 4 comma 2. So what you're going to do is then you'll check whether it's empty. No, it's not. You have two nodes, 1 and 2, with weights with distance 4 and 4. You're going to choose the one with the minimum. So the one with the minimum is going to be well, both are same. You can choose for the first one. You're going to poll this, okay, and you'll be left out with 4 comma 2 actually. Okay, you'll be having 4 comma 2 as a pair inside the uh, inside the priority queue. Okay, then you'll try to update this one, right? You won't update it, yeah. So you're going if you're going to update it, let's say it's not 4, let's say it's 9 and sits less than 9, and you're going to update it. In that case you will be adding to it. Okay, so in this case, if it's 9 and you're going to update it to 6, because 4 plus 2 is 6 and it's less than 9, and you're going to update it, then the priority will queue look like uh sit what's that, 6 comma 2, okay, rather than 4 comma 2. Okay, you'll update 4 comma 2 to 6 comma 2. Okay, but in this case you're going to retain it. Okay, so this is not going to happen, this is not going to happen. So you're going to have 4 comma 2 left in the priority queue. So when you come to this point, what you're going to do is you'll be having 4 comma 2, right? In your priority queue you'll be having 4 comma 2. So what you're going to do is you're going to poll it. So your queue is going to become empty at this point. Then what you're going to do is you're going to add whatever you have updated, right? So what are you going to do? You have updated this, right? So this, so this is 0, this is 0, this is 1, sorry about that, this is 2, this is 3, 4. Yeah, so you have updated this, right? So what you're going to do is you're going to uh, add all this to the priority queue. So 7 comma 3, 10 comma 5, sorry, okay, 5 comma 4 then. Yep, okay, sorry, this is 5 comma 4. Okay, so when you add this to the priority queue will use a comparator to find the to sort it and poll the to sort it with the mm, based on the minimum distance. Okay, minimum distance from the source node. So this node 3 has a distance of 7, node 5 has a distance of 10, node 4 has a distance of 5. So what you essentially will do in the next iteration is since this priority queue is not empty. Okay, so what you're going to do is you're going to poll this thing 5 comma 4, because that uh, 4 has a minimum value of 5. You're going to poll that. Yeah, so you're going to poll that and uh, check the, like repeat the same thing. So what you're going to do is you're going to poll, right? So now after you've polled 4 comma 5, sorry, 5 comma it's 4, right? You visited all this. So what you have left in your priority queue will be uh, 7 comma 3 and 10 comma 5, right? Yeah. So what you're going to do is you're going to you're going to remove this one 4 comma sorry 5 comma 4. The previous in the previous thing you had 5 comma 4. Now you won't be having 5 comma 4. You're going to remove that, and you're going to check its neighbors. So you have the last one 5 left here, and you're going to update the value of 5 to 8, right? So then you'll be adding it to the priority queue. Okay, so the priority queue now will become 7 comma 3. Okay, 10 comma 5, then 8 comma 5. Don't bother about this 10 comma 5. It won't affect the problem because this is a priority queue based on it works based on uh, a comparator, which is the minimum value of the minimum value in the first position of every pair. So this is the largest. So when you compare these two, always this will have the highest priority. This will not come up itself, so you don't have to worry about this at all. Okay, it'll be there, but uh, it won't affect the problem at all. Okay, so now you have all these values. You'll again check whether the thing is empty. Okay, you'll check whether it's empty. Then you'll find if it's not empty, and you'll choose the smallest one, which is 7 comma 3. Okay, and you'll remove it. Yeah, so you'll end up with 10 comma 5 and 8 comma 5. And you'll try to update 8. Let me put this. Yeah, now you have 10 comma 5 and 8 comma 5 in your priority queue, and you'll try to update the last one. You can't update it because obviously, sorry, obviously 9 is. Let me go to the next slide actually. Obviously 9 is uh, sorry. Obviously 9 is greater than 8, so you won't be updating it. So you'll just leave it, and finally you'll end up with the last one, and all its neighbors are already visited, so you won't be able to do anything with the last one. So the uh, will remove the last values from the priority queues as well, so the problem will be over. That's it. Okay, so as simple as that. I'll go through the code for this. Okay, yeah. Now we need a comparator to compare the minimum value. So what you'll do is we'll override that class actually. Okay, so what we're going to do is you're just going to compare, right? You're going to compare two values, right? So it's going to be you're going to compare two values and check whether the distance from the source node and which node has the smallest distance from the source node. That's going to be your priority. Okay, for this priority queue. Okay, so two pair objects. You're going to compare their Yeah. So this is how we have implemented the comparator actually. So this thing helps us to uh, helps us to help prioritize the values in our priority queue. Okay. So what you'll do is mm, okay. Now we have defined the priority queue. So we have to define the, the distance matrix as well. The distance array as well. So the distance array is nothing but array that contains the distance of every node from the source node. Okay, this is going to be a solution. This array is going to store our solution actually. Okay, so we have v number of nodes, right? So all those vertices. Now, so when you start this problem, as I said, you fill everything with infinity, right? Yeah. So that's what we are going to do now. We're going to fill every so we're going to consider every distance as infinity. So every node has a distance of infinity from the source node. That's what we have done here actually. Yeah. So now what you're going to do is you're going to initialize. Okay. You're going to uh, for the the distance array. Sorry, the source has a distance of 0, right? So the distance array contains the values of contains the distance uh, of every node from the source node. Okay, but the distance from the source node to itself is 0, right? So you're going to assign that. You had 0 in that. Uh, so here we had 0, right? Let me show you. Here we have 0, right? Yeah. So here we have 0, right? And every other nodes are assigned infinity, right? So the same thing we are doing there. Yeah. So what we have essentially done is, mm, let me show you. We have assigned maximum value to every node, okay, except the source node. Yeah. So the next thing is you're going to start with the first node, right? For with the source node, right? So you're going to uh, add a value to the priority queue. Okay. It's again going to be a pair object. As I said, as I told you, you're going to store it as a the distance from the source node. Okay, the distance from the source node and the current and the node itself. So we're going to 0 comma source. Okay, so what this means is in the priority queue now we have one value which is going to be uh, uh, the distance the distance of the source node from the source node and and the source node. I guess that's making sense actually. If you get confused, please comment. I will explain it there. Okay. Now this is going to be the main logic. Okay, the main part of the code actually. If this is not empty, if if the priority queue is not empty, you're going to poll a value and you're going to update its neighbors. Yeah, that's what we saw, right? So you're going to poll a value. Queue dot poll. Let's second. So what this will do is Uh, so in the PQ, every value contains the distance from the source node and the node itself, right? So second means you're kind of retrieving the node, okay, not the distance, okay. So next, you're going to iterate through all of its neighbors, okay, iterate through all of its neighbors. Yeah. So if you think you can update the neighbors uh, distance from the source node, you're going to update it and add it to the priority queue, okay. So uh, that's what you're going to do here, okay. So if the distance of the uh, current node from the source node, this understand this, if the distance of the current node from the source node is great sorry if the distance of the neighbor from the source node is greater than the distance of the current node, okay, from the source node plus the edge to the source node. Do you remember k plus edge from k to the neighbor set? That's what I'm doing right now, right here, okay. So if this condition is satisfied, then what you're going to do is you're going to update the distance, right? So distance dot I dot is equal to, you're going to update the distance, right? And now you're going to add uh, this thing, this updated node to the priority queue, okay. This is what we saw in this is what I explained right now. What you're going to do is you're going to add the distance from the source node, right, and the node itself. Yeah. Now this is done. Okay. So now what will happen is this will continuously run until every node is visited and the weights are updated, and finally you'll get the result. Let's write a let's write a for loop for printing all this uh, distance values. Okay. Yeah. So let's hope this works. So what I'm going to do is let's try this with our example. Okay. So our example has 6 nodes, right? And yeah, so this is the code for undirected graph. If you want a directed graph, you can simply remove this line. That's it. Okay, you can simply remove the second line uh, and it'll work for directed graph. That's it. As simple as that. Uh, yeah, as you can when it comes to directed graph, direction matters really. So if it's from source to destination, it doesn't mean it's from destination to source as well. So in that case, you can remove the second line, okay, for directed graph. So let's try this with our example actually. So let me check the example actually. So yes, guys, the example's kind of ready. Yeah. So uh, so yeah. So this is the example that I explained to you in the previous video, yeah, and we the same example that we went through for this video as well. So let's try to run this program. It's building. Let's see. Yes, it's done. Yeah. So if you can see for the zeroth node, uh, the distance from this, so the source node is going to be 0, right? And for the source node 0, the distance from the source node is 0. Yeah. And for the first node, the distance to the source node, the shortest path or the distance to the source node is 4. And you have the same for all the nodes in the graph. And if you really want to cross check with the answer that we saw in the last video, it's pretty much the same. If you see, you simply uh, have the same thing. Yeah. Sorry. Yeah. So for the zeroth node, you have 0. For the first node, you have 4. For the second node, you have 4. For the third node, you have 7. For the fourth node, you have 5, and the fifth node, you have 8. Similarly, uh, in the program output itself, we have the same answers for all the nodes as well. Yeah. See, for 0 we have 0, 1 we have 4, 2 we have 4, 3 we have 7, 4 we have 5, and 5 we have 8. So I hope you had a great understanding on this code, and I hope you really understand the extra algorithm. Then in the upcoming videos we'll have some examples, like some problem solving examples in which we can implement the extra algorithm and or single source short path algorithm. Till then, thanks.